Hi everyone, welcome to May 14th, Unit 8, Lesson 6, Electronic Technology for Physical Science. Today we're going to look at the digital lesson from our book. I'm then going to show you a couple other videos, one from Vocabulary and then one from pbslearningmedia.org. Your assignment will be to go to BrainPop at the end of this and to look at the internet, and then you'll email me your graded quiz. But first, let's take a look at the digital lesson.
If you were a runner in the 1970s, you would go to a track to make sure you were running exactly a mile. And to measure your heart rate, you would find your pulse, which is hard to do while running. Things sure have changed. Click the highlighted areas to discover some technology that has helped today's athlete. When done, click the next arrow to learn more about electronic technology. This runner is not wearing just any watch. This is a GPS watch. Runners used to have someone time their run. If they ran in their neighborhood, they couldn't be sure exactly how far they went. This watch sends signals to satellites. These satellites send signals back to the watch. When the runner has finished his workout, he can tell how far he ran, how fast he ran, and his average speed. Many runners like to know how hard they train by keeping track of their heart rate while they run. This runner wears a strap around his chest. It has sensors which pick up electrical impulses. The electrical impulses tell how fast the runner's heart is beating. These signals are sent to the watch. The runner can then adjust his training if he wants to increase or decrease his heart rate while exercising. Many athletes like to keep records of their training. These devices, along with a computer, can make tracking an athlete's training easier. The information from the GPS watch can be transmitted to a computer, either wirelessly or through cords. Displays such as graphs and logs let runners know how far and fast they ran on any given day. Runners can also keep track of their heart rates over a period of time. An athlete today can partner with technology to train smarter. Welcome to the lesson, Electronic Technology. In this lesson, you'll learn about electronic technology, how it began, and how it has become part of almost every aspect of our lives. The vocabulary words for this lesson are electronic device, integrated circuit, analog signal, digital signal, and computer. The first computers were big enough to fill a large room and required several human operators. Many early computers had only one function, and their parts burned out quickly. One of the earliest computers, built in the mid-1940s, weighed over 30 tons. Modern computers have applications for almost anything. They last for years, and technological advances allow new models to get smaller and faster all the time. Do you know the difference between electrical and electronic devices? Both are powered by the flow of electric current through them. Electrical devices convert electrical energy into another type of energy, while electronic devices actively control the current flowing through them to carry out a function. Click the images to learn about some different types of electronic devices. The earliest electronic devices were radio transmitters and receivers. A transmitter sends out radio waves that are broadcast from satellites and antenna towers. A receiver picks up these signals and converts them into sound waves. The electronic circuits and devices such as smartphones, radios, and scanners get their electrical energy from outside power sources, such as batteries or electrical outlets. The batteries in many electronic devices can be recharged. A smartphone is a handheld device that combines a telephone, a camera, and a computer. These devices use several different kinds of electronic circuits to help us stay organized and in touch, offering contact lists, calendars, instant messaging, email, internet browsers, and a growing number of other applications. The invention of the integrated circuit allowed electronic devices to become smaller, faster, and more powerful. An integrated circuit is a circuit whose components are formed on a single piece of a semiconductor material, such as silicon. This image shows an integrated circuit and other components on a circuit board. Click the highlighted areas to learn more about how an integrated circuit works. The terminal pins connect the integrated circuit to an electronic device. Silicon is a semiconductor. That means it conducts less current than a regular conductor, but more current than an insulator. How much it conducts depends on its temperature and on what other chemicals have been added to it. All the components of an integrated circuit are on the same silicon chip. Today, one integrated circuit can do everything that the first computers could do, and more. The connecting wires connect the integrated circuit to the terminal pins. Transistors amplify and switch electronic signals. These signals transmit information. A modern integrated circuit can be a few centimeters square, but have 1,000,000 transistors per square centimeter. Electric circuits are made of several parts. Which parts of a circuit can be used to amplify or switch electronic signals? Click all answers that are correct. That's right. Integrated circuits can contain millions of transistors that can amplify and switch electronic signals. Correct. Transistors amplify and switch electronic signals. Transistors are electronic components used as amplifiers or switches in electric circuits. Transistors are the primary building blocks of computers. The first integrated circuit was a piece of silicon that measured about 2 to 4 square millimeters and contained 15 to 20 transistors. Today, integrated circuits can contain millions of transistors. Computers and other devices can be made smaller and can run faster using integrated circuits. Many of the devices we use every day use integrated circuits to function. Some might surprise you. Click play to discover some ways that integrated circuits are used. Even a gas stove uses integrated circuits to run its clock and timer. The integrated circuits in a phone send and receive phone messages. A microwave oven uses integrated circuits to control how foods and beverages are heated and to signal when they are ready. Electronic thermostats have integrated circuits that help us control the temperature in our homes. Computers use a variety of integrated circuits to crunch numbers, process words, play games, and surf the internet. A computer is a device that accepts data and instructions through an input device, follows the instructions, and outputs the results. Data may be input through a keyboard or mouse, and output using a monitor or printer. The first computers, such as the Analytical Engine designed by Charles Babbage and the Z1 built by Conrad Zuse, were mechanical. Click the timeline to learn how electronic computers were developed and how they have changed over the years. Dr. John Atanasoff conceived the idea for the world's first electronic digital computing device in 1937, and Clifford Berry built and successfully tested it in 1942. The Atanasoff-Berry computer, or ABC, was not programmable and could only solve systems of linear equations. Its results were stored on paper cards. In 1945, the U.S. Army completed final assembly of a computer called ENIAC, which was over 24 meters long, 3 meters high, and weighed 27 metric tons. Operators frequently had to replace the vacuum tubes that the computer used to control the electronic signal, as they burned out quickly. ENIAC was used to calculate numerical solutions to problems in such areas as atomic energy and targeting weapons. In 1959, the integrated circuit, or microchip, was introduced. It allowed the development of much smaller computers. The term personal computer was coined in 1975 to describe a computer kit that had to be assembled by the customer. Today, desktop computers come in a wide variety of shapes and sizes and can be connected to many different devices. By 1981, improvements in microprocessor chips enabled computers to become small enough to be truly portable. Microprocessors have become so powerful that inexpensive handheld calculators can now do everything ENIAC could do and more. First introduced in 1992, the smartphone integrates a cell phone with a handheld computer. Now we can place a call while surfing the internet wherever we are. A signal is anything that is used to send information using a carrier. Information in an electronic device can be coded by varying the current in the circuits of the device. Click play at the points along the bar to learn about the two types of signals or codes transmitted by electronic devices. This clock dial uses an analog signal. The properties of that signal can change continuously within a given range. The hands on the dial of this clock move continuously around the dial in a smooth fashion. Analog signals for radios and televisions send a copy of the original sound or picture. This clock uses a digital signal. This kind of signal can be represented as a sequence of discrete or separate values. It isn't continuous like an analog signal. The second counter on this digital clock jumps from 1 second to another. Similarly, a digital sound recorder changes a sound wave into a coded digital signal that's represented as a sequence of separate values. The signal is encoded using only 2 digits, 0 and 1. You've learned that analog signals are continuous, while digital signals are sequences of discrete values. Click each picture to learn more about analog and digital signals. This aneroid barometer uses a continuous analog signal that is used to show atmospheric pressure. Both laptop and desktop computers are digital computers. They process digital signals that can be represented as binary numbers. These numbers are made up of only 2 types of digits, zeros and ones. When a transistor on a computer chip is open, an electrical pulse can flow through the computer. This is represented as a 1. When a transistor is closed, no electrical pulse can flow. This is represented as a 0. Each digit is referred to as a binary digit, or bit. Information is transmitted by the pattern of ones and zeros formed in this manner. Some of these objects use analog signals to process information, while others use digital signals to do so. Drag each image to the correct box. That's right. You are able to sort the objects into those that use analog signals and those that use digital signals. Analog signals are continuous, while digital signals are sequences of separate values. Continue on to learn about other ways computers are used in society. As computers continue to get smaller, faster, and more powerful, they are used in more and more ways. Click the images to learn more about some of the ways computers are used in society. Computers are used in medicine in a variety of ways. They store and process important medical records and bills. They help in the diagnosis and treatment of patients. They even help doctors perform delicate surgeries that would otherwise be impossible. Computers help farmers gather information from the internet to help their businesses. Tractors, combines, and other types of farm machinery use GPS, or Global Positioning System technology, to improve the way they water and fertilize crops. The ATM at a bank is a computer that allows us to make withdrawals or deposits of money any time of the day or night. Computers are changing the way students learn and teachers teach. A teacher can use a computer whiteboard to display interactive lessons to a class. Students in remote areas can learn from teachers far away through online courses. Computers help us communicate with other people from a distance and gather information conveniently through the internet. Students from one school can communicate with students from another school on the other side of the world. You've learned that computers have changed over time. Identify the different computers shown here by dragging the labels to the correct images. Good job! You've matched them all. ENIAC was a large early computer. A personal desktop computer can be hooked up to a printer. A laptop is very portable, and a smartphone can fit in your hand or pocket. Computers store information as binary numbers that only use the digits 0 and 1. Which of the outputs shown here indicates that a computer did not emit an electrical pulse? Click the correct one. Not quite. Correct. There's no 1 in this output, only zeros. This means that no electrical pulse was emitted. Whether a digit in a binary number is a 0 or a 1 depends on whether a tiny electronic switch is open or closed. If it is open, an electrical pulse can flow, and the digit is a 1. If the switch is closed, the pulse cannot flow, and the digit is a 0. How do you think life has changed in the past 20 years as a result of the computer's development and advancements in computer technology? Type your answer in the box provided, then click OK.
All right, I'll have to skip over that as we aren't able to do that.
You've learned a lot about electronic technology, how it has changed, and how it has changed the way we live. Let's review the main ideas from the lesson. Electronic devices work by actively controlling the flow of electricity from a power source to carry out some function. The invention of integrated circuits allowed electronic devices to become smaller, faster, and more powerful. Information in an electronic device can be coded by varying the current in the circuits of the device, using transistors as electronic switches. An analog signal is a signal whose properties can change continuously within a given range. A digital signal is one that is represented as a sequence of separate values called binary numbers, made up of only 2 digits, 1 and 0. Computers and other electronic devices are changing the way we live. As we continue to improve electronic devices and introduce new ones, their impact on society will continue to grow. Now that you've finished this lesson, if you wish, you can go back and review any part of the lesson again.
All right, I'm going to show you just 2 different clips. This one is from Vocabulary, and it is, what is the internet?
Haven't had dinner yet. I'm about to serve food for thought on the internet, so you understand, and it doesn't make your head hurt. The first thing we need to do is define a network. Any 2 computers connected that can communicate make up a network, man. Examples include a computer lab at school or computers in the office. Yeah, that's true. Networks can be connected with wires or wirelessly, whatever you desire. The internet is a worldwide network composed of smaller networks. I'm an expert. Underground fiber optic cables are the coolest. They connect networks throughout the U.S. and cables at the bottom of oceans. Listen here, they connect networks across the hemispheres. That's the only reason someone in Iraq or another hemisphere can watch the Weekend rap. And one more thing that might sound like a fable: sometimes sharks try to chew through a cable.
Whole world right in front of you. With all this information, what will you do? The internet lets everyone connect. Communication from here to Tibet.
Hey, yo, this beat'll make your neck jerk. And now you know the internet is the world's largest computer network. But how does a device like a tablet access the internet? Sounds like magic, but no magician, so don't get nervous. There's a system that works like a delivery service. In order to send something to someplace, you need to know where it starts and where it will go. So for your device to access a website, kids, you need an address for where the website lives. And everything that receives and sends information also has an address, kind of like a location. The address is called its Internet Protocol, IP address for short. Opposite of tall, but you don't need to know the IP address. You just need to know the domain name to gain access. The domain name is the website's name. Type it in your browser. It's a part of the game. Once you make a request on your device, routers sending flying like kites. A router is a device that transmits data between different networks. It happens behind the scenes. The data goes to a server, best known as the computer that can fulfill the request. The request can take one of many paths, and once it's delivered, the server responds back. The response will probably take a different path back to you depending on the traffic, like when you're in a vehicle.
The whole world right in front of you. With all this information, what will you do? The internet lets everyone connect. Communication from here to Tibet.
Okay, this last video clip I'm going to show you is from PBS Learning and PBS Learning Media, and it is titled How Computers Compute.
Even though we think of computers as super complicated high-tech machines with very tiny parts, they can also be huge, wooden, and mechanical, just like this computer here. And even though they look very different, they're both made of the same basic part, a switch. One switch doesn't seem very interesting. It's either off or on. But if we arrange switches in a specific pattern, we can do math or logic. For instance, this circuit turns on the light if both switches are turned on. But this circuit turns on the light if either or both switches are turned on. If we connect more switches, we can do more complex math or logic. So fundamentally, a computer is just a carefully constructed arrangement of switches. A light switch has a mechanical input and an electrical output, but because the input and output types are different, we can't connect the output of one to the input of another. In order to make more complicated circuits, we need a switch with the same input and output types so that we can string a bunch of switches together. Our Digicomp has switches with a mechanical input and mechanical output. Just like a light switch, these switches have two states, either left and right, off and on, or 0 and 1. What's really cool here is that instead of programming this computer by writing code, we program it by physically setting the position of several different switches. I'll now set this computer to count the number of balls in the top tray by setting the count switch to on. The sum is given by this bank of switches here. We'll set the sum to 0 before we start counting. Now let's start counting by pressing this lever. Problem the computer solved was 0, 0, 0, 0, 0, 0, 0, plus 1. As the ball goes through the system, it changes the first switch from a 0 to a 1, so that the sum now reads 0, 0, 0, 0, 0, 0, 1, or simply 1. Now let's count the second ball. So what happened this time? I'll reset the sum back to 1. The math problem that we solved was 0, 0, 0, 0, 0, 0, 1 plus 1. The Digicomp adds 1 to the first switch, but since it's already full, it carries the 1 to the second switch. The sum ends up being 0, 0, 0, 0, 0, 1, 0, which is 2 in binary. Let's count the third ball. can see that the sum is now 0000011, which is 3 in binary. In addition to counting, the digicomp can add, subtract, multiply, and divide. The number of switches determines how big the numbers can be. This digicomp has 31 switches and can count up to 127. But modern computer chips have over 1 billion switches. They're made from wafers such as this one, where each square represents a chip. They're made from semiconductor switches called transistors, which have the advantage of being solid state, meaning they have no moving parts. This allows engineers like me to make them smaller, faster, and more energy efficient. We can make them over 1 billion times faster than the digicomp. These semiconductor switches make modern electronics possible.
All right, last thing. So when you're finished watching this, I'm going to ask you to go on to BrainPop. And I'm going to ask you today to type in the internet. You'll see there are a number of different search results and topics that they have. So for today, I'm going to ask you to go into internet. I'll ask you to watch the movie and then take the graded quiz. And again, as always, there's other information here that you can take a look at. So today you'll, again, like I said, go into BrainPop and type in internet and then email me your graded quiz result. Tomorrow's lesson, if you look on the learning plan, it will ask you to go back to BrainPop again and then to search computer history. And then do the same thing, take the graded quiz and email me the results. Also in packet 4, you have a worksheet titled computer history. So I'll ask for you to complete that as well. I hope that you have a great day. If you have any questions, please email me at heidi.younger@centrahealth.com. Again, as always, try your best, and I hope to talk to you soon.